In this section, we'll be taking a look at the Configuring and Monitoring VPLS objective of the JNCIP SP exam. For more detailed coverage of this topic, please check out the Juniper courses AJSPR, JL2V, and JL3V. In this video, we're going to be looking at the configuration and operation of VPLS, or Virtual Private LAN Service. And in this video in particular, we're going to be focusing on BGP signaled VPLS. And to do this, we're turning to this network that's shown on the screen. And you can see that it's very similar to the network that we've used to demonstrate BGP and LDP signaled point-to-point layer 2 VPNs and layer 2 virtual circuits. The difference with VPLS being that we have an emulated broadcast segment interconnecting all sites, rather than having separate point-to-point links between our sites. Remember that with VPLS, we're achieving that broadcast segment by binding together those individual point-to-point links into an emulated broadcast domain. So let's now jump onto PER1 and see how we configure VPLS. So with BGP signaled VPLS, we're using the same address family as we were using for BGP signaled layer 2 VPNs. In fact, there's an awful lot in common with how we're configuring VPLS as we are configuring BGP signaled layer 2 VPNs, if we are indeed using BGP signaling. We're configuring a routing instance, much like we did for layer 2 VPNs. The difference being here is we're specifying instance type VPLS. We then associate all our CE-facing interfaces with our routing instance. We configure a route distinguisher and a route target. And then we configure protocols. In this case, we're configuring protocols VPLS rather than protocols L2VPN. But essentially, the configuration is doing much the same thing. We're associating a unique site identifier with a local interface. The big difference here is that we don't have any association with remote site identifiers this time. That's because we want to be creating point-to-point links to every remote site within this VPLS domain rather than just specific ones, because that's how we're going to be achieving our emulated broadcast segment. And another thing to note finally is that configuring the PE to CE interfaces, we're using a different encapsulation style. We're using VLAN VPLS instead of VLAN CCC. So as I've mentioned, the mechanics under the hood are very similar to layer 2 VPN operation. And we'll be advertising our layer 2 NLRIs across our IBGP mesh to all other PEs. We'll be using that routing information to establish a full mesh of point-to-point links that we can then use to send our Ethernet traffic over. So let's have a look at the BGP Layer 2 VPN routing table. There we see our routes that we're familiar with from L2VPN with our route distinguisher and our remote site ID. So a quick look in more detail. They're practically identical to what we would see in a layer 2 VPN environment. One of the main differences is, of course, we're using a different encapsulation style now. We're using VPLS rather than, say, Ethernet or Ethernet VLAN. And the sharing of these routes is what allows us to establish our point-to-point connections. And we can view those, again, in much the same manner as we would with layer 2 VPNs. We do a show VPLS connections. That's going to show us all of the point-to-point links in our VPLS domain. We can see here that we have 2 established point-to-point links connecting to our other PEs. Go back to the diagram. So we've got a point-to-point link going from R1 to R6 and from R1 to R2. And the same is true on R2 and R6. So we have a automatic full mesh of point-to-point links making up our broadcast segment. One of the key differences now with VPLS is that we are now performing MAC learning over this full mesh of point-to-point links. So we can associate source MAC address with incoming interface. And that way, when we have frames destined for that MAC address, we can unicast them out across the necessary point-to-point link rather than having to broadcast them. Let's have a look at that table on R1 now. At the moment, you can see that there's nothing in the MAC table. This is because there's no traffic operating on this LAN. We drop to one of the CE devices and we ping the remote CE IPs within this LAN. This should be sufficient for our PE to learn where those MAC addresses are located. And we've done that. You can see that we have a MAC address associated with the PE to C local interface. And we have MAC addresses associated with our virtual tunnel interfaces that are being used to decapsulate the received MPLS traffic to then read inside the source MAC address and associate MAC addresses with the LSPs that are routing to remote PEs. And that way you can quickly ascertain where all the MACs for a given VPLS domain are located. In this video, we took a quick look at VPLS configuration and VPLS operation.